Welcome to Dev Network's Developer Week webinar series. I'm Patrick Gallagher, and I'd like to welcome all of you to this week's featured webinar, How Mobile Game Cheats Unlock App Security Lessons. And this week's webinar is presented by GuardSquare. Before we get started with speaker introductions, I've got some housekeeping items we need to quickly review. Number one, live chat and Q&A is available during the session. And you can also raise your hand in the chat or ask questions in the Q&A section of the webinar viewer. We will address your questions at the end of the presentation, but please get those questions in as you have them. There are handouts available. So on your viewer on the right-hand side where the Q&A and chat is, there's also a tab for handouts. Go ahead and be sure to click on that section to download the materials before the end of the webinar. And number three, this webinar will be recorded and made available within 24 to 48 hours after the event for additional viewing. So it'll be emailed to you so you can take a look at it. It'll be emailed out to those people who couldn't make it today. And you can also have an opportunity of forwarding that email and that webinar link to your coworkers as you see fit. So joining us today is Jan Serendinsky, the mobile application security engineer at GuardSquare. So without further delay, please give your undivided attention to Jan.
Hello, my name is Jan Seredyński, and today I'll talk about cheating in mobile games and how the same cheats can be reused in regular apps. So here I'll show you a number of techniques that attackers use to actually cheat in games. And I'll also show you techniques that allows you to, for example, walk through walls. And let's start from a short demo. Here we can see Among Us. That was quite a popular game in 2020. And we are that red player in the center. And obviously, we are not allowed to just walk through walls. But, well, an attacker can do that one. And it's pretty simple. We just need to turn into a ghost, and once we are a ghost, we can just cross any wall. So yeah, firstly, we just go through the wall, and once we are on the left side of the wall, we can just switch back into being a human and continue with the game. I will show you a lot of techniques like that. I will show you how it works and how attackers just get it to work. But apart from that, I'll show you way more techniques. I will cover how attackers bypass payment screen and touch ID screens, so they don't need to pay for many in-app purchases. Also, I'll show you how people can download paid apps for free. So there are more app stores than only the original app stores. The original app store. There are plenty of alternative ones, and it applies to App Store and for Google Play too. Then I will show you that a lot of those apps inside those alternative stores have many premium features unlocked. I'll just show you how attackers unlock them and how easy it actually is. And then I'll show you how attackers can tamper with the memory to, for example, modify the number of diamonds in a game. Well, so for each of those attacks, I'll show you how to protect against those attacks. And you just need to follow 4 simple guidelines to protect your app. And that is environment integrity, application integrity, code integrity, and obfuscation. But I'll come back to that later on. So firstly, let's start from getting diamonds for free in a game. And here I have an example of Tamagotchi that was quite a popular app in 2020. So let's open the game. And here you can see that we have 1,478 diamonds. Well, the diamonds are premium currency in a game, and we need to pay for it. And here I'll show you how to actually get them for free, how just people get it for free in games. So firstly, I'll just show you how much you need to pay for diamonds. So you can see it's big money here. And in a second, I'll just show you how easy it is for others to modify that number in your game. So firstly, we just need to enable a memory scanner for the application, which is just going to another app and triggering a switch. Then we open Tamagotchi app again, and you will see in a second that there is a new pop-up, that red gear over here in front of the fridge, which is just the memory scanner overlay. So right now we can tap on it and we can search any variable inside the memory. And we will just search for 1478. And let's tap on it. And here we can just search for exactly that number. And once we search for it, the memory scanner will list all of the addresses inside the memory where that value is. Well, obviously, there is more than only one, because there could be some other values, not only diamonds. There could be a price for a pool for Tamagotchi or whatever. So let's actually buy something for 1 diamond. So it can be, for example, a sushi. So right now we have 1 diamond less, and let's filter out those addresses here, those values in the memory. And right now we can see that only one variable has actually our value of diamonds. So we need to just modify that value inside the memory directly. So we can just tap on that value with that memory scanner. We can just change it to whatever value we actually want. Let it be 777. And right now we just close the memory scanner, and we can see that the number of diamonds hasn't changed, but actually it has. So right now we have 777 diamonds, but the graphics of the game isn't refreshed yet. So let's close the app and let's open it again. It will allow the graphic to refresh. And you will see that the number of diamonds has changed to the exact number of our choice. Yeah, here you can see that one. Just by simply searching throughout the whole memory and editing the variable over there, we were able to modify that value to 777. So before I tell you how it works, I will show you one more example, because those two are quite similar. But that one is about bypassing payments. So here, it is another, I believe, quite popular app. You could find it in top 20 in 2020. So here, we have an app, and in here, we have a lot of ads. Like top left corner, there is an ad, and on the bottom, there is another ad. And if you want to remove an ad from that game, you just need to tap on here to just remove those ads. But once you tap on it, you will see a payment pop-up that you need to pay for ads. Well, obviously, hackers don't pay for that kind of stuff, and I'll show you how easy it is actually to bypass that kind of protections. So firstly, we just need to attach to the application. And once we are attached to the application, we can invoke any function of our choice. So here, I just invoked a function on transaction succeed. And that function would be invoked after we would pay for the purchase. Well, obviously, we won't pay for the purchase here. I just invoked that function right now. So let's tap on cancel at that point. And the application will close. So let's open it again. And you will see that we don't have ads anymore right now. So you can see that there is no ad here, no ad here, and there is also no that button over there. So we actually paid for not showing ads for the premium account without paying for it. We just invoked a function that would be invoked after a successful payment. And in a second, I will show you why that one actually worked. But what's important here is that we can use the same technique to bypass the Touch ID screen. The Touch ID screen. And well, all of those techniques that I'm showing here apply for Android and for iOS. So it doesn't matter which platform I'm showing right now. So let's go here, and protecting against those kinds of attacks is called environment integrity. And I was actually able to attach to the app and scan the memory because the system was compromised. And protecting against the compromised environment is called environment integrity. So we can say that environment is compromised when, for example, a device is jailbroken or rooted. But it's also when our app is emulated. But also we can have the whole system emulated. Then we can also do the same stuff. And if we don't implement any environment integrity inside our app, there are many threats. Like, for example, someone can just invoke any function, as we just did for bypassing payments. Or someone can scan the whole memory for variables and just tamper one of them. Or, well, if you have a jailbroken device or a rooted device, we can install some software from third-party package managers and just tamper with the memory, as we did with the memory scanner. So we can just install a memory scanner from online, and then we just don't need any hacking skills to actually hack an app, because it's just like an overlay on the application. We just need to tap on it, search for a specific value, and then modify it. I showed it to you based on memory scanner, but there are way more tweaks like that. And a lot of apps a lot of companies were actually victims of that kind of attack. So, for example, an attacker can invoke a function that would bring him on the top of the leaderboard. And, well, the attacker could, for example, pass an argument to a function that would say that he did more kilometers, more miles than other players with, for example, shorter time. So he would get higher in the leaderboard. So invoking functions inside the app is quite dangerous here. And right now, I'll show you how you can actually protect your app on your own. So firstly, a compromised system leaves behind a lot of footprints in the file system. For example, on iOS, there is a bash file that we can find inside bin directory. And on Android, there is so file that we can find inside sbin. And we can just look for them with an API. It can be lstat, it can be open, an API that is available on our platform. Then we should also check if some new applications are installed. For example, on iOS, we can find Cydia quite often on a jailbroken device. And, well, Cydia registers a URL inside the system, which is exactly that URL, and we can just check if that URL is registered. And on Android, it looks a bit different. We can just ask the package manager to list all of the applications installed and check if Magisk is in there. And Magisk is a quite popular app that we can find on rooted devices. Then another way to protect your app is process properties. So the operating system keeps track of process properties. And properties, for example, mean whether an app can modify itself in the runtime. So, for example, if there is a cskill flag present in our properties, it means that the operating system should kill the application if it tries to modify itself in the runtime. If we download an app from App Store, there should always be that flag present. So we can, because Apple doesn't allow apps to modify themselves. So we can check whether that API returns that flag. And if it doesn't, it means something fishy is going on right now. On Android, it looks quite similar, but we can ask the system if it allows system-wide debugging. Well, generally, the system-wide debugging is not allowed, so if the system allows for it, it means that something is wrong. Also, on Android, we can check whether we are running in the emulator right now. So we can, for example, ask the Android SDK what's the name of the device we are running on right now. So we can use build.model for it, and if the name contains an emulator string, it means that we are probably running on an emulator. If you are looking for more advanced ways to protect against an emulator, on Android, you can use NDK. There, you just need to use some machine instructions, some very, very rare machine instructions that could be not supported inside an emulator, because many emulators don't implement all of the instruction set. They just choose the most important ones and implement them. So if we try to run very rare machine instruction, the behavior of an app may differ than on real processor. For more ideas on protecting the environment, I recommend going to OWASP MSTG. You can find a few ideas more there, but those ideas that I covered over here should be definitely enough for basic protection. So right now, another topic, how people install a paid app for free. So there are more app stores than the only one app store. There are more Google Play stores than only the one original. And they are called alternative stores or third-party stores. And there we can find a lot of apps for free. So for example, inside App Store, we can find Minecraft for almost €8, but we can get it for free also from a third-party store for free. And right now, I'll just show you how it works. So firstly, an attacker needs to buy a paid app from App Store, Google Play, and then install it on their device. And once that the application is installed, they can download an IPA file on iOS or APK file for Android. They can download it from the device to the computer. And once the attacker has an APK file, they can share it with anyone. They can share it with their friend or with a community or just distribute it online. So when the attacker has the APK file, they can just send it anywhere. And once they can send it, they can just make it free. They can just upload it and give link to someone, so anyone can just grab it from there and install on their device. But what's more, when an attacker has an APK file, they can modify its content. So there are many games and apps where we have, for example, maps inside our APK. And those maps can be defined in a JSON file. Like here in that game, we had the normal map, and then we had a JSON file that reflected those cubes inside the map. So for example, the number 174 is just a river here. So why don't we just create a huge G letter out of those rivers? But also, if there was, for example, a hard monster to fight with, we could just remove him from the map. So we should definitely protect our APK from it. And now I'll tell you how exactly it works. So let's say we downloaded that IPA or APK file, and APK file is actually just a zip file. It's just an archive. The same for IPA. So we can unzip it and we can just browse through the directories and find, for example, a map that we want to modify. And it's easy as just browsing into those files, choosing the right map, and replacing those numbers here. But what's more, you can also add new resources. So in that case, you could just add a new map. But what's more scary is that an attacker could inject a whole new dynamic library with new functionality. So that could be just anything right now, just even a new feature or new premium capabilities of our hero. But also it could be malware. So that could be anything. Protecting against those kinds of attacks is called application integrity, and it is about verifying whether the app's resources hasn't changed, like for example the JSON file for the map, or we can check if the app is installed from a legitimate source. So we want to just make sure that the application is downloaded from App Store or Google Play than from an alternative store. So if you don't do that one, someone can just download our app for free, and that app can also contain some built-in cheats, new assets, modified assets, but also some hidden malware. But what's also quite important here, an attacker can just repackage our app in a way that others can attach a debugger to it. And that one is actually quite dangerous, because if someone can attach a debugger, they can imitate any behavior as it was possible on a compromised system. So we can invoke any function or scan the memory or override variables inside the memory. So here, so there is a common belief that you need to have a jailbroken or rooted phone to hack apps, which is totally not true. You just need to repackage your app in a way that it allows to attach you a debugger, and then you can do the same. You can invoke functions, scan the memory, override memory. So you can do all of that one. And a lot of apps were actually victims of that kind of attack. So there are many apps that are just tutorials, and they are repackaged with just new courses that are for free, so people don't pay anymore to their developers. Or there are, for example, paid apps that were paid in original store, but people don't need to pay for them anymore. So how do you protect against it? On iOS, you can check for the signature of an APK. Well, but you can also do it on Android. So the main thing here is that you can just check in the runtime the package name. So when an attacker resigns your application, they change also the package name. So in the runtime, you should always verify if your package name hasn't changed. Also, you can check if the application was signed with your certificate. If it's signed with someone else's, then it means that something wrong just happened, and someone else just signed our app. Also, you should check some files in your app package. So you just saw that we just modified a JSON file with a map, and you can checksum it or create a hash of the JSON file and verify it in the runtime. And if those hashes don't match, it means that someone just changed the file, changed the map. So we should act accordingly. Well, on Android, you can also find all of the hashes and checksums inside the meta-int directory. So you even don't need to check it on your own. You can just use those checksums from the directory. Also, you should check if your app is debugged right now or generally debuggable. Because if your app is debuggable, then someone can imitate the compromised system, like invoking functions, as we just talked about a second ago. So on iOS, if an app is debugged right now, you can use ptrace, and once you use ptrace, the application will crash immediately when the debugger is attached. Also, you can check for the parent PID of the process. So whenever you start an app on iOS, whenever you start that app from the main menu, its parent PID is always 1. And if you start an app with a debugger, then a debugger has for sure other PID than number 1. So check for it. And if your PID, well, if your parent PID is not equal to 1, then it means a debugger started our app. Also, we can use the process properties. We can just check if we are debugged right now, because the system will just say to us with that flag. On Android, it's quite similar. We can just check the Android manifest.xml and find there a debuggable flag. And if it's set to true, it means that other applications can attach a debugger to our app. But on Android, we can also check if an application has a debugger attached right now, and we can check it with that API debug is debugger connected. For more ideas, I recommend going to OWASP MSTG. But again, if you implement those 3, that should be for sure enough for a basic protection. So now I will switch to another topic. It's about unlocking premium content. So there are many apps in those third-party stores, in those alternative stores that are hacked in many ways. So for example, in Plant vs. Zombies, we can see that an attacker just modified it in a way that right now the user has unlimited number of coins, gems, or mints. And well, it's not only that app, it's also, well, there is like honestly countless of apps like that in those third-party stores with unlimited money, towers, players, heroes, anything there. But it doesn't only apply to games. You can find a lot of regular apps that were also patched. So for example, Duolingo, I don't remember correctly, but I think that you can retake an exam 3 or 4 times there. If you want to retake it one more time, you need to wait, I believe, a day or 2, and then you can retake it again. But you can always pay for a premium account, and then you can retake the exam as many times as you want. So, well, but if you download that app from a third-party stores, it is modified in a way that allows, well, that activates the premium feature and unlocks all of the courses, because some courses may not be just free. And right now, I will show you how attackers actually patch those games. So let's look at the top left window, the developer's view. So here we are a developer that tries to check the license. And we have a function, check license, that takes a string argument with the license. And there inside, we just create an isValid local variable. We set it to false by default. Then we just validate our license on the server. And well, if it returns true, then we change isValid to true, and then we just return. And attacker doesn't see the code, doesn't see the source code. The attacker doesn't see Swift, Objective-C, Java, Kotlin, or anything like that. An attacker can just see assembly or Smalley code. So it's a bit harder to actually understand the logic of the code from the hacker's view, but the attacker can easily see where are the if statements. So if you look at those branches here in the graph, like for example, the red one that goes to the left and the green one that goes to the right, that is just the if statement. And here, if we just take the left branch, we can see that here we just move number 1 into one register, which is just setting true into isValid variable. So we can easily see that that part is just the the closure, the inside closure of that if statement here. And an attacker can just look at those lines just behind the branch and see what's going on. So firstly, we can see that we are invoking validate license on server, which is quite straightforward. We are just invoking it. And then we are just doing tbz instruction. And we can check in documentation that it means check if return value is 0. So we check if the return value is 0. And if it's not 0, we take that left branch. If it's 0, then we take the other one. And if we take that one, then we set to true. So right now, our goal is to change that instruction into the opposite. We just need to reverse that one. So if you look at the top at the bottom left corner, you can see that we have tbz, which is check if return value is 0. But if you want to reverse it, we just need to add n here. And then we just check if return value is not 0. So here, we can just easily reverse the if statement. So whenever the validate license on server returns false, it will always be true in our case. So protecting against that kind of attack is called code integrity. And it is about verifying if the machine code or Java instructions haven't changed. And if we don't implement the code integrity, then there are some possible threats, like someone can unlock premium content, as they did for many apps or for many games, or if we don't implement code integrity, our ads can be removed, or some constraints, or even bypass authorization screens. And here we can see a few apps that were hacked. Well, we talked already about Duolingo, but there is another app, Typorama, that allows you to add text on images with some filters. But in there, you need to pay for different filters. You just need to pay for any filter there. But you can find, well, on a third-party store, on alternative store, you can find a version of Typorama that has everything purchased, that has all of the filters purchased. So you can just grab it from there and have it for free. But there are way more apps like that one. And here I'll show you how not to let your app end up like that one. So here, firstly, we should check our code. So here we can see the check license. We know that function pretty well already. And in that function, we just changed the tbz instruction. So we want to protect our function in a way that the tbz instruction won't be changed. And we can do it just by verifying those all instructions in the runtime. So each instruction has an opcode. An opcode, it is just like 4 bytes in ARM processor that defines an instruction. So when anything inside the instruction changes, then we have different opcodes. So basically, we need to find our function inside the memory. We just need to find that address, and we just need to check the opcodes. We can, for example, add all of those opcodes and check if the sum of it is the same as during the compilation. So here we can see a short snippet of code. It is just a for loop that starts with the first address of the function and iterates until the last address of the function, and we just increment by 4 because one instruction in ARM architecture is just 4 bytes. So we just take opcode from each address, so just reference that memory, we just take opcode and add the opcode to our hash. And at the end, we just check if that hash hasn't changed since the time we compiled it. On Android, we can do something a bit different. We can just check, we can just verify the hash of the binary. Well, we have the NDK. We can just check if anything changed there, or we can just look up the classes.dex and we can just hash it. We can just checksum it. And if it differs in the runtime, it means that something was changed in our code. Also, there are swizzled methods. So a swizzled method is a method for which the function pointer was changed. And if we try to invoke that function, another function will be invoked instead. So a fake function will be invoked instead. And you can find more about it on a blog post from my colleague from GuardSquare. It explains exactly what the method swizzling is and will tell you how to protect it on iOS, but also gives you some tips on Android so you can understand the whole logic behind that one. So right now we will go back to the first demo from that webinar that was about walking through walls. So everything in that example starts from symbols. So symbols, well, a symbol is just a name of a class or a function or a variable inside the application. So we actually dumped all of the symbols from Among Us. It doesn't matter if it's IPA or APK on iOS or Android. We can just dump those symbols, and there we can see in the clear text what developers wrote there. We can just see the class name, like player control, and all of the methods there, like die, revive, setskin, and more. And our plan of attack was to find a relevant function that would allow us to, well, hopefully walk through walls and then invoke that function. And we already know that we can invoke the function in many different ways. If we have a compromised system, like jailbroken device or rooted, we can attach to the app at any time and invoke any function. If we don't check for application integrity and we can just attach a debugger to the application, we can also invoke any function. But if we don't check for code integrity, someone can just modify our app, someone can just patch it and invoke that function. So we decided to try to die and then revive. So we actually get close to a wall, then we invoked die, we went through the wall, and then we just invoked revive function. And it's easy as that. We just need to find the right function inside the app and invoke it. And we can do it on many ways. We don't need to have a jailbroken phone or a rooted phone. And if you remember the third demo where we bypassed payments, there we actually used onTransactionSucceed method. And we found it in a very similar way. So we actually dumped all of the symbols from the application. We found onTransactionSucceed, and then you can just think that, oh, wait, that function can be actually invoked after a successful transaction. So let's call it. And once you call it, you will see that that's the function that actually removes all of the ads inside the application. And here you can also ask yourself, how many meaningful names, symbols do you have in your app? And right now, I'll tell you about obfuscation. So obfuscation is about making it much harder for an attacker to understand your code. So it is about renaming variables, methods, classes, so an attacker won't find it as easy as we did a second ago. But it's also about encrypting strings, keys, tokens, API endpoints. So here, let's say that we have some key or a token inside our application that allows us to communicate with a third-party server. And if an attacker steals the token, they can spoof some request, some HTTP request there. So if an attacker can just take our app and find token inside string section, inside data section, then it will be just too easy for them to spoof some network there. Also, we can complicate the control flow graph. So you know that right now we can use the control flow graph to spot if statements and just change the one instruction before the if statement. But we can make the whole control flow graph we can just convert the whole control flow graph into a very, very complex form. So it's super hard for an attacker to actually understand what's going on there. But we can also encrypt assets. So let's say you want to make a surprise for your customers or for players and prepare special set of assets for holidays, but you don't want to reveal them just yet. So you just put them into your application and you decrypt them during the holidays or just the first day of the holidays. And if an attacker can find it before you reveal it, that could damage the whole surprise. So obfuscation is all about those points here. And if you don't implement obfuscation, then it's easier for an attacker to reverse your app statically. So an attacker doesn't even need to run your app once. They can just get everything from the APK file. Also, if your app has, for example, some API to modify an image, then that API is actually just one function that takes as an argument the image. Then an attacker can just find the name of that function and can just take the whole function from your binary and just copy it and paste it into their code. So that's why we should actually make our control flow graph harder and make our functions depend on others. So it's not that easy to extract our code. And the same is for API scraping. So if an attacker can get the endpoints to the servers, then they can attack the server directly. So many apps have only mobile application, not the web client. So if you have the mobile client, we can just keep our endpoints for ourselves. We can just create an SSL pinning so no one can proxy our traffic and find those backend endpoints. So the attacker won't attack the backend directly. And there are many companies that actually reverse engineer apps and discover their secret API and then implement clients for them. So, if you don't want your app to be investigated by attackers and also different companies, then you should think about implementing some obfuscation. And right now, I'll show you how to protect your app with obfuscation on your own. So, firstly, developers should write clean code, and obfuscation is about the opposite. So, obfuscation is actually about writing ugly code. It's about choosing wrong names. It's about making our code so complicated that an attacker won't understand it. So, that's why it's actually good here to have a compiled time solution than do it on your own. And in case of symbols, there is a free tool from GuardSquare. It is called ProGuard that you can use on your app to obfuscate all of your symbols. For obfuscating the control flow graph, I don't know any free tool, but if you want to try it on your own, you can just create a very complex control flow here. Like you can, for example, create a while loop that would execute only once, because then we can have if statement. for sure break out from the loop, and then you can put your sensitive code here. You can also add some switch cases in there. And once you have everything there, the control flow graph will be definitely a way harder. Also, for an obfuscation, you should encrypt your resources, and you can do it in many ways. Like, for example, you can XOR the encrypted text with a key, for example. Okay, so right now, now I want to talk why you actually need to have all of these components to make your app secure. So if we don't have our environment integrity, then an attacker can just easily bypass application integrity. So right now, if an attacker tries to put our app into alternative store, and then, well, obviously we have application integrity, so we check for the certificate. But right now, if we don't have environment integrity, the attacker doesn't need to resign the application. Because even if the attacker changes anything in the application and don't resign it, then the application will still run on the system, because the compromised system often doesn't check for a valid signature. So if we don't do that one, then other parts just are weak. If we don't implement application integrity, then it just requires one extra step to imitate compromised environment. So someone can just repackage an app in a way that it allows attaching debugger. And once we have a debugger attached, we can invoke any function of our choice. So we basically imitate the compromised environment. Then if we don't have code integrity, someone can overwrite our protection code. Right now, we already know a lot of ways to protect our app. We know how to check for Cydia, for Magisk, and others. And well, we also know how to patch the code, like we patched the check license. So an attacker can patch our code in the same way. So we should just check if our code isn't changed. And then in obfuscation, if we don't have obfuscation, it's easier for an attacker to find relevant functions. So we already know how easy it was to spot some functions in Among Us or the other game. And right now, we know why we actually need to implement all of this, that we need to implement environment integrity, application integrity, code integrity, and obfuscation. You know ways to implement it yourself. But before you go and implement it yourself, I just want you to remember about a few things. Firstly, update your protection code regularly, because if you don't, you will just give enough time for an attacker to understand your protections. So if you keep your protections in the same place all the time, then after a couple of months, an attacker will understand how they work and they will just bypass them. So make sure you just put them in random places, and you should just change those places as often as you can. Ideally, you should change it with every build, every upload to App Store or Google Play. So it differs. The same for symbols and so on. They should differ with each upload. Then you should make sure that your protections will work on new iOS and Android versions. So right now you can create a protection that works on iOS and Android, but let's say that a new minor version of iOS is released tomorrow, and then your protection just don't work. So make sure to have big variety of checks and just check your protections with every release of new versions. But what's more important, you should check for false positives, because if a new iOS version arrives and your protection always triggers, then an application may just crash on your customer's device. So make sure to check all of the beta versions of new Android and iOS versions. before, so you have time to update your protections. Okay, that would be it. And I believe now it's the time for Q&A section. Thanks a lot.
Yes, it is, Jan. Thank you very much. Great presentation. So it does look like we have some questions. If we want to go to the Q&A section of the viewer, we've got a few questions if we want to start from the top. The first question, what if my app gets uploaded to a third-party store? How can I protect them?
Well, so if our app is already in a third-party store, then it really depends on the application. Well, always you can write an official complaint to a third-party store and ask them to put the app down. But I believe that one won't work. And well, you can, well, probably your application will just remain hacked, but you can just implement new protections for new versions. And from that point onward, it should be safe. But the other thing that comes to my mind, you can always change your backend endpoints, but that may not be always enough because many attackers cache responses from the backend and just insert it with the whole app. So that's not always the way to bypass that. So just implement your protections in the new version of your app.
All right, great. So the second question, could you also use iGameGod for cheats like wall hacking in online games?
So, well, the demo that we showed with Among Us, that one worked for the multiplayer mode. And I believe that inside iGameGod or other third-party stores, you can find a lot of other versions of Among Us that allows to do the same. And it's not only Among Us, probably you can find a lot of games, like online games, that allows you to cheat like that.
Got it. The third question, would the bypassing payments method not be easily defeated by just inlining these kinds of functions?
So, well, that's true. If we validate those purchases on the backend side, that would be perfect. But well, we checked quite a lot of apps from App Store and from Google Play, and we looked at like top 30 apps, and I think at least 7 of them it was possible to bypass them in a way we actually did here. So the ideal way is to implement the verifier on the backend side, but a lot of apps just don't do it. So yeah, but the best way is to do it on the backend side.
Understood. Fourth question, I know there are open source obfuscators and RASP frameworks. Would you recommend using those?
Mm-hmm. Well, so there are a lot of open source RASP libraries. And well, obviously, I think it's great that people share it and we should use it. The only thing that I'm a bit worried about is that they are open source. So anyone know the code. So an attacker can just see that we are just using that framework for the protection, and then they can just see the source code of it, and they will just know how to bypass it because they know the code. So it's just better if we do something custom. We can just take the ideas from those open sourced Rust products, I mean Rust repos, and implement them inside our app. But I'm really not in favor of adding them to our projects like they are.
Great. Next question. Does the getting free diamonds memory modification technique really work in a lot of cases? I would think that it would cause memory issues, making the app crash or something similar. Or at least many games use backend to store all such player data. In that case, would it not work correctly or right?
Mm-hmm. Well, not every game can actually send data to the server and wait for the answer because there are a lot of real-time games and they need to cache some variables on the client side. And mostly in that case, you can use the memory scanners, but also a lot of games allow you to actually work offline. And in that case, the memory scanner can be also used. But well, there are also a lot of apps like the Tamagotchi app that is an online app, but we were also able to tamper with the memory. So there are for sure a lot of apps that don't validate memory with the backend.
Great. Next question. How widely used are third-party app stores? I know Apple has quite a closed ecosystem. Is it really easy for anyone to access and use those stores?
I believe I had even a slide on that one, so let me go back to it. And yeah, here. So right here, you can see the number of downloads. For example, for Plants vs. Zombie, Bloons, and Duolingo. So, well, you can judge numbers on your own. I believe it's quite a lot. And it's just one alternative stores, but there are way more stores than only iGameGod. And that one comes from iOS Gods. So I think that's a big issue right now.
Okay. Next question. One thing, Jan. What about parental control on games? Does it break this feature in coding? Thanks.
The parental, you mean, does it help against the memory tampering? Or I'm not sure. Well, so generally, if you have the parental control, it doesn't protect us against the memory tampering or bypassing in-app purchases. Well, you should rather go for the backend validation or implementing those protections inside your client. So I don't think that parental control would help here.
Okay. Next question. Is the getting free diamonds trick something you can easily detect as an app developer? Is there an easy way to do this without requiring back-end validation?
Well, you can, well, so people that have those memory scanners installed need to have a rooted device or a jailbroken device. So if you detect a jailbroken phone or a rooted phone, then you should just refuse to open. But if you want to let your players to use jailbroken phones, I believe that in that case, you should always encrypt your variable. So store it encrypted on the heap somewhere, and then once you need to use it, decrypt it, use it, and then encrypt it back. So two ways, or use encryption for it, or detect jailbreak or rooted device, just the whole environment integrity thing.
Great. So we have two more questions left. The second to last, if I compile with GuardSquare, how much does it add to my app size?
Well, that one really depends on the amount of protections you want to inject. So if you want your app to be super complex, then it will probably inject a bit more code. So it would be a bit bigger. But also, if you use the GuardSquare compiler, we optimize a lot of code, so it also shrinks a bit. I can't say any number because it depends on the application and the configuration. So it really depends. It depends on how secure you want to have your app. I can't answer that exactly.
Understood. And the last question, and before we finish with the last question, I just want to make sure everybody is aware and looking at the screen. Jan's email address is on the screen. So if you have additional questions for Jan after the fact, you can email him at his email address on the screen. You can also visit GuardSquare's website as well. So the last question, how often jailbreak detection logic needs to be kicked in? Good enough to check only at the time to be launched, or more aggressively at the time whenever the app goes to foreground. Is that recommended?
So, well, for sure you should check it when you launch the application, because, well, when you launch the application, and you crash immediately, it's a way harder for an attacker to spot where you use those protections. So if you put your protections into initializers inside, mostly initializers, then it is super hard for an attacker to spot it, because if you put it later on in the application, like after you press a button, then an attacker knows that the code that runs so far doesn't do anything, and then the attacker will just focus on steps that would happen after you press the button. But at the same time, an attacker can, for example, attach a debugger after. So an attacker can, for example, run the application from the menu, and after, let's say, 5 seconds or 10 seconds or 1 minute, can attach a debugger. So you should check for jailbreak, for debuggers and others when you launch the application, but also later on. So do it regularly. After a few seconds, the best. Well, actually, seconds, maybe it's not the best metrics here. Probably you should decide on your own when to do it. Maybe you can do it on some important functions that happens quite often in your app.
Understood. Well, Jan, thank you very much for a great presentation. There were several comments thanking you for such a great conversation in the chat. So I do want to thank you as well as GuardSquare for the sponsorship of today's online learning session. And before we end, I do want to hit some final housekeeping items. Number one, as a reminder again, just said it, but I'm going to say it again. If you have any additional questions for Jan, his email is up there on the screen, and we'll be there just for a couple more moments before we close out the webinar. So make sure that you go there and copy that down if you have some additional questions. There's also a reminder that we have handouts available. So here in the viewer, if you have not downloaded the handouts yet, please do go to the handouts area and download that now, because we're going to be closing out the webinar here in just a few moments. Also, there is a recording of the session that will be available 24 to 48 hours for your review. It'll be forwarded to those who attended today's, as well as people who registered for today's webinar. And you can also forward that information onto your coworkers so that they can see the webinar as well. And this recording will be added to DevNetwork and the Developer Week content archive, and that can be found at devnetwork.com with a slew of other webinars and online learning opportunities from past days. So Jan, thank you very much for your time. And I want to thank all of our attendees for participating, and we all want to wish you a great and happy day. Bye now.
Thank you.